Welcome to the project demonstration of solar wireless electrical vehicle charging system using wireless power transmission concept. So here the main application of this project is we are representing this toy car as an electrical vehicle which will get the power by this wireless power transmission. So in real time we are going to place these coils on the road for direct power of the electrical vehicles, or else if you want to charging of electrical vehicles, if this particular vehicle consists of a battery that can be recharged with help of wireless power transmission. So here the concept is wireless power transmission. To achieve this concept, we need to convert our signal to required frequency. Nothing but we should get around 150 kilohertz, minimum 100 kilohertz to 150 kilohertz of AC signal need to be provided for this copper coil to get the maximum EMF. So whenever we get the maximum EMF, so that then whenever we place the receiving coil, then it will get induced and will get the sufficient voltage at sufficient distance. Based on the frequency and the power, the EMF region will be defined, and when we place the secondary coil, then it will get induced. So for that purpose, we are going to convert AC to DC initially when we want to charge a battery, because we need to get our required frequency, so that we should have a DC power supply only. So when we talking about the DC, which is can be storable in a battery and which is can be rechargeable with help of renewable sources like solar panel. So whenever the sunlight is not available, then it won't get the sufficient voltage to charge a battery pack. So for that we are making use of a grid also. See, means we can charge this battery pack with help of solar panel as well as from the grid. So here the charging time either from the solar panel or from the grid is 5 to 6 hours. We should place this solar panel under the full sunlight so that the battery will get charged in a 5 to 6 hours of duration. If we place the both sources at a time, yes, we can provide the solar panel along with transformer grid also, means both can be provided at a time, so it will get fully charged in a duration of 1.5 hour to 2 hours only, as we are getting the more power from the two sources. So this is a charging circuit unit, so which has a rectifier and filter and two diodes which will act as a unidirectional current flow. The rectifier will rectify the AC to pulsating DC, filter will remove the pulses and provide as a pure DC, and unidirectional current flow diodes are useful to block the current flow from the battery to this transformer. Same on this charging circuit, which is of the solar panel also. Just connect the solar panel at these 2 pin slots. Okay, and now so here these 4 diodes will acting as a polarity correctors, means we are providing the DC, then these 4 diodes will not act as a AC to DC converters, they will acting as a polarity correctors, means when we place the solar panel in reverse polarity, reverse bias, means minus to plus, plus to minus, then these diodes will correct that to plus, minus to minus. So that is again given to the battery pack through the same unidirectional current flow, which is block the current flow from the battery to the solar panel. So this is about the charging circuits. Just place the, if you want to charge a battery from transformer, just connect that to the 230 volts. There we get indication of battery, like a light indication which will show the status of battery is charging till the respected time, means for minimum 5 hours. Keep the battery under charging either from the solar panel or from the grid. Once the battery is fully charged, we can utilize that just on this. So the light indicated showing the status of transmitter is getting switched on. So whenever this receiving coil coming on this, there you can see the light indicated on this EV. Right, so around this much of distance the power is transmitting. Right, okay. So when it is away from the coil, then there is no induced EMF will be done, so that there is no signal. So this will get the same signal of 150 kilohertz of frequency of AC signal, and that will be converted into the DC 5 volts with the help of this regulated power supply board, and the output is given as input to this load directly. So in the advanced version, we can place a battery or real-time electrical vehicle or any robotic kind of vehicle for presentation purpose. So we can see the both indication on this RPS board as well as on this LED indication, load. Right. Thank you.